read the equation to their terms. It says when a number can be expressed as the ratio of two whole numbers, it is said to be rational. You should know this already from last year. Thus, all integers, all fractions, proper and improper, all terminating decimals, and all repeating decimals are rational. When two numbers cannot be expressed as the ratio of two whole numbers, it is said to be irrational. All surds are irrational. The definition of a surd is when the roots of a rational number cannot be obtained exactly. The root is called a surd. Surd is when the root of a rational number cannot be obtained exactly. Numbers such as thus the root of 2, the cube root of 4, the fifth root of 18 are surds. A rational number may be written in surd form, thus 2 is equal to the root of 4, 1/3 is equal to the root of 1/9, or the cube root of 1 over 27. But the root of 4 and the root of 1/9, etc., are not surds. They are merely written in surd form. The order of surds, it says the order of a surd is indicated by the index of the root sign. So, for example, the cube root of 2 is the third order, is of the third order because there is a 3 right there. The nth root of a, the surd has an nth order because there's an n right there. It's very small, but it's right there. So a surd of the second order, examples of surds of the second order are square root of 3, square root of 5, are called quadratic surds. So these are things that you have to know. You have to know what you're talking about when we're talking about the order of a surd. Hopefully, yeah, you should have had time to read this section and extract your notes. Because remember, this is not a regular classroom, so it's asynchronous, which means that you have to do some part synchronous and asynchronous. It's a blended approach, which means that I give you the notes ahead of time. You should extract what you understood to be the most important, all right, for your own notes, which I know some of you lack in doing. So let's look at the rest. It says a comparison of surds of different orders. Surds of a different orders are compared by expressing them as a surd of the same order, which is the greater. So for example, the root of 2 and the cube root of 3, right? The common order in which you can express two surds is at the LCM, or the lowest common multiple of the given order. So the LCM of 2 and 3 is 6. So the square root of 2, which is equal to 2 raised to the half, and let's make this a little bigger. It seems that we may need it. We need to make it a little larger so that you can see the powers are very, very small. So as I said, the square root of 2, which is equal to 2 to the half, can also be expressed as equaling 2 raised to the 3/6. So hence, this third form is going to be the 6th root of 3 to the third, which is the same thing as saying the 6th root of 8, because 2 to the third is 8. Similarly, the cube root of 3 is equal to 3 raised to the 1/3. Well, since the LCM of 3 and 2 is 8, when we evaluate it, or we want to compare it, we have to make 3 have a power of something over 6. So that is going to be 3 equals to 2/6, which is equal to the 6th root of 3 to the second, which is equal to the 6th root of 9, since 3 to the second is 9. Hence, if we're comparing it, the 6th root of 8 and the 6th root of 9, obviously that means the 6th root of 9 is larger than the 6th root of 8. So hence the cube root of 3 is greater than the square root of 2. Just making you understand this section because it's very important. Multiplication of surds. It says simple surds such as the root of 2 times the root of 2 equals 2 to the power of a half times 2 to the power of a half, which equals 2 to the half plus a half, which is simply equal to 2 to the first power, or just simply 2, which is a rational number. So that means in general, the general rule is that if I have the square root of a times the square root of a, that's like saying a to the half times a to the half, which is the same thing as saying a to the half plus a half, and you know under the laws of indices, half plus a half is 1. So it will equal a to the first, which we simply call it e, which is also a rational number. So hence, that means that anything that is the root of a number times itself will always give you the number without the square root. Just making sure you understand that. So here we have the square root of 2 times the square root of 3 equals 2 to the half times 3 to the half, which can be written as 2 open bracket 2 times 3 close the bracket r raised to the half, since both of them have the same power, which is equal to, well, 2 times 3 is 6, but you have to keep the power of a half, which is outside the bracket, which will equal the square root of 6. So in general, the square root of a times the square root of b is equal to a to the half times b to the half, which is the same thing as saying open bracket ab close bracket raised to the half, which is equal to the square root of AB. Right? So that is very important. So we've looked already at 2 general laws. The first law is the square root of something times itself, and then the square root of A times the square root of B. Very important rules. Also, 2 over square root of 2 equals root of 2. In general, a over the square root of a will equal the root of a. The reason being we're going to discuss as we move along. The fourth rule, the root of a over the root of b is equal to a to the half over b to the half, which can be written or is equal to open bracket a over b close the bracket raised to the half, which is equal to the square root of AB. Alright? Let me stop there for a second. Alright, let me stop there.